Hi everyone. All right, so this is section 1.2 in your book. We're talking about direct variation, and I don't really care for the definition of direct variation that's in that book, although if you want to refer to it, that's fine. I prefer the definition mathematical relationship between two variables that can be expressed by an equation in which one variable is equal to a constant times the other. And the constant of variation then is the number that relates to two variables that are directly proportional or inversely proportional to one another. And we'll talk about inverse proportions later. Tonight we're just going to be talking about the direct proportionals or direct proportions or direct variation. So there's the general form, which is that's the equation version of that long definition. It's just y equals k times x, where k is the constant of variation. It's a constant. Notice that it's very similar to our y equals mx plus b, right? So it's a linear equation. It just doesn't have, well, it does have a y-intercept, but that y-intercept is at 0 because the graph of a direct variation equation always passes through the origin. So b would be 0. Y-intercept is at 0. The constant of variation then is calculated just by manipulating that equation, right? We start with y equals k times x, where our constant is k. These are our input and output variables, same as they ever were. And we figure out what k is by dividing both sides by x, right? So we just get y equals, let me rewrite it, kx, divide both sides by x, we get y over x equals k. And this might look a little bit like some of the things we did in geometry last year when we were talking about proportions. If it does, you know, good on you. If it doesn't, well, we'll get there. So notice that y over x is the ratio of output values to input values. It's a ratio, right? Y over x equals k. And that ratio is constant in a direct variation. So every y value over its respective x value is going to give you the same k, right? It's going to evaluate to the same number. Let's see what that's all about in a second. So there are ways to identify direct variations. You can do it from tables, from equations, and from graphs. And by this point, we're pretty well accustomed to that, right? So if we had an equation, excuse me, I thought I had it queued up, and I don't. So if we had, for instance, a table. Wait, hang on. I do have it queued up. There we go. Can we tell from this table whether or not we have a direct variation? Well, yeah, because if we have a direct variation, each y over x is going to equal the same k. So we divide 5 by 2, and that equals 2.5, right? We divide 12.5 divided by 5, and that equals 2.5. And then we divide 25 by 10, and look at that, it equals 2.5. Because these are the same number, we have a direct variation. The constant of variation then is 2.5. That's how we tell from a table. We just divide each y by its corresponding x, and if the numbers come out, evaluate the same way to the same number, then we have a direct variation. That's how we tell from tables. How do we tell from an equation? Well, we just have to simplify, right? So we want something of the form y equals kx. That's what we're looking for, ultimately. Let's simplify this equation. We're going to add 3 to both sides. We get 6x equals 2y. Right away it looks like maybe we have a direct variation, right? So let's divide both sides by 2. We want to isolate our y. Divide both sides by 2, we get 3x equals y. That is a direct variation. It's backwards, but it is equivalent to y equals 3x. We don't have a y-intercept. We just have a constant of variation, and it's 3. Also the slope of the line that goes through the origin. Whoa, hey, where's my graph? All right, well, let's draw a graph. If I had a graph that looks something like, let's just graph. Hang on. Whoops. Still with me? Let's do a graph that looks something like this. How would we know if this is a direct variation? Well, we have a linear equation, right? So it's a line. Whatever our equation is, it generated a linear graph, and it's going through the origin. There's our direct variation, right? It could also look something like that. We could have a negative variation, right? A negative slope, but they're all going to go through the origin with some slope. The reason that works is because if they go through the origin, here's our general form, right? Y equals mx plus b. If they go through the origin, what's the y-intercept? It's 0. Now we have a direct variation. Instead of slope, the m for slope, we change it to k for x, but these are the same number. They're the same thing. We just express them using a different letter in the general form than in the direct variation form. Okay, so that's it. I want to see all of this stuff in your notes. Tomorrow I will check your notes, and then we'll do lots of practice problems like we always do. Have a good night, everyone.